Let's take a look at sum and difference formulas. And first, go over our formulas. We have the sum ones first. We have cosine of alpha plus beta is equal to cosine alpha cosine beta minus sine alpha sine beta. We have sine alpha plus beta is equal to sine alpha cosine beta plus cosine alpha sine beta. And tangent alpha plus beta is equal to tangent alpha plus tangent beta all over 1 minus tangent alpha tangent beta. Now we have our difference formulas. If we have cosine of alpha minus beta, then we can rewrite it as cosine alpha cosine beta plus sine alpha sine beta. And sine alpha minus beta is equal to sine alpha cosine beta minus cosine alpha sine beta. And tangent alpha minus beta is equal to tangent alpha minus tangent beta all over 1 plus tangent alpha tangent beta. These formulas these problems are meant to get you used to working with those formulas. That's their main purpose. Let's look at our first one. It says find the exact value of each expression. Well, we got sine of 11 pi over 12. We're going to try to rewrite 11 pi over 12 as either a sum or difference of two angles on a unicircle. So first thing we need to do is get our values the same as in terms of the denominator as what's on a unicircle. I was listening to what's going on in my house instead of focusing on this. Okay. Well, this over here is pi over 6. This is pi over 4. This is pi over 3. And this is pi over 2. This is 2 pi over 3. This is 5 pi over 6. And 3 pi over 4. Well, the denominator here is 12, so let's rewrite all these with 12. So here, multiply the bottom part by 2, multiply the top part by 2, so 2 pi over 12. Here, multiply the bottom part by 3, so that gives us 3 pi over 12. Here, multiply the bottom part by 4, so we've got 4 pi over 12. And this is 6 pi over 12. This is 8 pi over 12. And this is 9 pi over 12. And this one is times 2, 10 pi over 12. Now, pi here is 12 pi over 12, if we were to need it. Okay, so we got sine of 11 pi over 12. And I'm looking through here. I'm trying to figure out 2 added together or subtracted give me 11 pi. That's 17. This would be 15, 13, 12. 9 pi and 2 pi gives me 11 pi. So I can rewrite it that way. So this becomes sine of 9 pi over 12 plus 2 pi over 12. So we were able to write it as 2 angles added together from our unicircle. Well, the formula I'm going to use is sine of alpha plus beta. Sine of alpha plus beta is this one right here. Now this is the formula we're going to plug it into. So recall, sine alpha plus beta is equal to sine alpha cosine beta plus cosine alpha sine beta. Now this would be our alpha, and this would be our beta. So this becomes, from our formula, sine alpha, so sine 9 pi over 12, then cosine beta, which is 2 pi over 12, plus cosine alpha, which is 9 pi over 12, and sine beta, which is 2 pi over 12. Probably best to put these back into their simplified form that matches our unit circle. So sine of 3 pi over 4, cosine of pi over 6. And this is cosine of 3 pi over 4, and sine of pi over 6. Well, sine of 3 pi over 4 is square root of 2 over 2. Cosine of pi over 6 is square root of 3 over 2. Cosine of 3 pi over 4 is negative square root of 2 over 2. And sine of pi over 6 is equal to 1/2. There we go. Now let me get my unit circle. So I should be pointing that out, because if you're not comfortable with it, then you wonder where in the world do those come from. Okay, sine of 3 pi over 4. 3 pi over 4, sine is our y, so that's square root of 2 over 2. Cosine pi over 6. Pi over 6, cosine is our x, which is square root of 3 over 2. Over here, cosine of 3 pi over 4. Cosine is our x, which is negative square root of 2 over 2. And sine pi over 6. Here's pi over 6, sine is our y, which is 1/2. Okay, now we can simplify this. Square root of 2 times square root of 3 is square root of 6. 2 times 2 is 4. Minus square root of 2 times 1 is square root of 2, and 2 times 2 is 4. And merge those into a single fraction. We've got square root of 6 minus square root of 2 over 4. And that's our answer. And I think I got may have room. We'll see. I have to write a little bit smaller. Tangent 17 pi over 12. I hate to start a new page because well, this is what we need right here. 17 pi over 12. There's 12, but there's no 5. 10, but there's no 7. 9 pi and 8 pi. That gives you 17 pi. So 9 pi and 8 pi. So it's 9 pi over 12 plus 8 pi over 12. I'm going to go ahead and simplify them before I put them into that formula, but this is 3 pi over 4, and this is 2 pi over 3. Top and bottom both divisible by 4. This is going to be alpha, and this will be beta. Don't hardly have room there. Oh well. Our formula, tangent alpha plus beta, is equal to this. And so recall tangent alpha plus beta is equal to tangent alpha plus tangent beta. So tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. Okay, so this part right here becomes tangent alpha, so tangent of 3 pi over 4 plus, was plus, wasn't it? Yeah, plus tangent beta, so tangent 2 pi over 3 over 1 minus tangent alpha. So tangent 3 pi over 4. Tangent beta, which is 2 pi over 3. Okay, tangent 3 pi over 4. That's equal to negative 1. Okay, here's 3 pi over 4. Tangent y over x. So put this over this. They're the same, so it's 1. And since they're different signs, and that's why it gives us a negative 1. Plus tangent 2 pi over 3. Here's 2 pi over 3. Tangent is y over x. And 2's would cancel away since they're the same. So I'd have square root of 3 over negative 1 or negative square root of 3. Okay, and then down here I'm going to have tangent 3 pi over 4 again, which is negative 1, times negative square root of 3. So we got minus 1 minus square root of 3. 1, negative is positive, times another negative is negative. So 1 minus square root of 3. Well, we can't have the square root downstairs, so we'll multiply top and bottom by the conjugate of the bottom. Conjugate is the first is the same, the second part is the same, but the sign in the middle is different. So it's 1 and the square root of 3 are the same, but it's a plus in the middle. And whatever you multiply by the bottom, you have to multiply by the top. Now up on top, when I multiply these together, I get negative 1 times 1. That gives us negative 1. Negative 1 times square root of 3 is negative square root of 3. Negative square root of 3 times 1 is negative square root of 3. And negative times a negative is positive. And square root of 3 times square root of 3 gives you 3. Now down below, let me double check that. Okay, negative 1, negative, okay, yeah. Down below, since they're conjugates, all I have to do is multiply first parts together and last parts. So I'll take 1 times 1, gives me 1. Negative times positive is negative, and square root of 3 times square root of 3 is 3. So up on top, we got 3 minus 1, which gives us 2, minus 1 square root of 3 minus 1 square root of 3 is, well, they're both negative, but negative 2 square root of 3. Since the radicals are the same, you can combine together numbers in front. 1 minus 3 is negative 2. From college algebra, you remember if you can divide this number, and this number by the same number, do so. They're all divisible by 2, so that gives me 1 minus square root of 3 over negative 1, which gives us negative 1 plus square root of 3. And assuming I didn't mess up on a sign somewhere, or multiply, or add wrong, or something like that. I'm double checking my work here real quick. And that looks like our answer. Okay, so let me save this. What section is this? This is sum and difference formulas. Page 01. There we go. I think I'm done with that. Okay, so let's look at our next problem. Find the exact value of each expression. Now in this one, we're trying to rewrite the 75 degrees as two angles added or subtracted to give you that. Now I'm not very good with decimals, so let me actually look here. Difference is 75. Okay, 120 minus 30 is 90 times that. 120 minus 45, that's 75. So we can rewrite this as secant 120 degrees minus 45 degrees. Well, we don't have a formula for secant. If we look over here, we just got cosine and sine and tangent. Well, that's easy enough. Secant is 1 over cosine. So I can rewrite it that way. Now this will be our alpha, and this will be our beta. And then from our formula, cosine of alpha minus beta is going to equal to cosine alpha minus beta. Cosine alpha, cosine beta. So cosine alpha, cosine beta, plus sine alpha, sine beta. There we go. Okay. So the bottom part becomes, this is alpha, so we got cosine of 120 degrees, and cosine beta, which is 45 degrees, plus sine alpha, so sine of 120 degrees, times sine beta, which is sine of 45 degrees. Cosine 120 degrees. Cosine is our x part, which is negative 1/2. That's negative 1/2. Cosine 45 degrees is square root of 2 over 2. Cosine is our x part. Sine of 120 is square root of 3 over 2. 120. Sine is our y, which is square root of 3 over 2. And sine of 45 degrees is square root of 2 over 2, if I look it up. Okay, so we got 1 over, and that gives us negative square root of 2 over 4, plus square root of 3 times square root of 3, square root of 3 times square root of 2 is square root of 6. 2 times 2 is 4. Now we can multiply everything by 4 to get rid of that, the fraction inside. Like this. So then we get 4 up on top here. Here these 4's would cancel, leaves us negative square root of 2. These 4's would cancel, leaves us square root of 6. Now we can't have a radical downstairs like that. So what we can do is we can multiply top and bottom by the conjugate of that, which would be negative square root of 2 minus square root of 6. And negative square root of 2 minus square root of 6. Whatever you multiply by the bottom, you have to multiply by the top. Again, conjugate, first part is the same, second part is the same, sign in the middle is different. Well, up on top, I got 4 times negative square root of 2 minus square root of 6. On the bottom, since they're conjugates, all I have to do is multiply my first parts together and my last parts. Well, negative square root of 2 times negative square root of 2, negative times negative is positive, and square root of 2 times square root of 2 is 2. Positive square root of 6 times a negative square root of 6 is negative 6. Now I can factor a negative out of the top part if I wanted to, so that gives me a negative 4. And then we've got square root of 2 plus square root of 6. And 2 minus 4 gives me a negative 4. And I see now the negative 4's cancel. And we've got square root of 2 plus square root of 6. And that's our answer. Let's look at our next problem. Okay. It says find the exact value of each expression. So we got cosine of 85 degrees and cosine of 25 degrees plus sine of 85 degrees and sine of 25 degrees. Well, I'm trying to find a formula that matches this. So if I come over here, I'm looking for, what am I looking for? Cosine, cosine, sine, sine. Cosine, cosine, sine, sine. Here's this, if there's a plus between them. Let's go look. Plus, yeah. So it matches this one, which means we want to rewrite it as cosine alpha minus beta. Well, this would be our alpha, and this would be our beta, and we want to rewrite it using cosine alpha minus beta. Again, we look to see which one it matched here. And cosine, cosine, sine, sine was this one. So we write cosine alpha minus beta. So this becomes cosine of 85 degrees minus 25 degrees, which is, what is that? 60? Yeah, 60 degrees. Now 60 degrees cosine is equal to 1/2. 60 degrees cosine is our x part, which is 1/2. Yeah, let me save that. There we go. And let's look at the next problem. Looks like another one to match. So we got sine of 7 pi over 15, cosine of pi over 5, plus cosine of 7 pi over 15, sine of pi over 5. Okay. Sine cosine plus cosine sine. Sine cosine plus cosine sine. Sine cosine plus cosine sine. Looks like number 2. So we're going to rewrite that as sine alpha plus beta. Now this will be our alpha, and this will be our beta. And we want to rewrite it using sine alpha plus beta. So this right here becomes sine of 7 pi over 15 plus pi over 5. Well, we need to get a common denominator, merge these together. So we got 7 pi over 15. Here, multiply the bottom part by 3, so we have to multiply the top part by 3. And that gives us 10 pi over 15. Top and bottom both divisible by 5, and that gives us 2 pi over 3. Now, sine is our y part, which is at 2 pi over 3. 2 pi over 3, square root of 3 over 2. So that's our answer. Let's see. This looks like a pretty long problem. But I could do part of it on this page because it might not even fit on just one sheet there itself. So let me do part of it here. Okay, so give us cosine alpha is equal to square root of 7 over 9. And it's in quadrant 1. Okay, and then they give us sine beta is equal to negative 2/3. And it's going to fall in quadrant 4. Right there. Okay. Now they're asking us to find sine alpha plus beta, sine alpha minus beta, cosine alpha plus beta, and tangent alpha minus beta. If I go look at my formulas, they need sine, cosine, and then tangent. So what we want first is over here, these are our alpha side. We want all of our trig functions for alpha in terms of sine, cosine, and tangent. Well, we're given cosine. So cosine of alpha is equal to square root of 7 over 9. And cosine is equal to x over r. So x is equal to square root of 7 and r is equal to 9. Well, we got x squared plus y squared is equal to r squared. So we got square root of 7 squared plus y squared is equal to r squared, which is 9 squared. So that's 7 plus y squared is equal to 81. Take 7 over. And that gives us 74. Drop the squared and put a plus or minus square root on the other side. Don't think that simplifies any. We're in quadrant 1, so everything's positive, so y is positive. Okay. Now, we said we need sine alpha. Sine is equal to y over r. So it's square root of 74 over r, and r was 9. We also need tangent alpha. That's equal to y over x. Y was square root of 74, and x is square root of 7. Well, can't have the square root there, so multiply top and bottom by square root of 7. 518. And that's 7. Is that right? 8, 2, 49, 51. Yep, that looks right. Okay, so those are our alphas. Well, we want to do the same thing with the beta. Okay, so they tell us that sine beta is equal to negative 2/3. And sine is equal to y over r. So y is going to equal negative 2, and r is equal to 3. So we've got x squared plus y squared is equal to r squared. X squared plus y is negative 2, so we've got negative 2 squared is equal to 3 squared. So x squared plus 4 is equal to 9. Take 4 over, becomes a negative 4, and we get x squared is equal to 5. Drop the squared, put a plus or minus square root on the other side. Now we're dealing with quadrant 4, and down in quadrant 4 x values are positive, so x would equal square root of 5. Okay. Well, we got sine beta, so we're going to need cosine beta. Cosine is x over r, and we just said that was square root of 5, and r is 3. We'll probably need tangent beta, which is y over x. Y was negative 2, and x is square root of 5. So that gives me negative 2 square root of 5 over 5. And let me write these down. Darn it. There we go. Because we'll need them in the next part. So we got cosine of alpha is square root of 7 over 9. Sine alpha is square root of 74 over 9. Tangent alpha is equal to square root of 518 over 7. Sine beta is negative 2/3. And cosine beta is equal to square root of 5 over 3. And tangent beta is negative 2 square root of 5 over 5. Okay. Now let me save this. And we'll continue this problem. Number 6. And first thing they're wanting us to find is sine alpha plus beta. Well, let me get situated here. Try to get a little air in my room here. There. Okay. Sine alpha plus beta. Let's go right down a formula. Sine alpha plus beta is sine alpha cosine beta. Sine alpha cosine beta plus cosine alpha sine beta. Okay, now from the previous page, we said sine alpha was square root of 74 over 9. Cosine beta, we said was square root of 5 over 3. Plus cosine alpha, which we said was square root of 7 over 9. Times sine beta, which was negative 2/3. Okay, multiply those together and I get square root of 370 over 27 minus 2 square root of 7 over 27. And merge those together and we get square root of 370 minus 2 square root of 7 over 27. Okay, let's find B. B was cosine alpha plus beta. So cosine alpha plus beta. So from our formulas, cosine alpha plus beta is cosine alpha cosine beta. So cosine alpha cosine beta plus sine alpha sine beta. Okay, I lie. It's a minus between there. There we go. It's kind of important part to get these right is actually write them down correctly. Now from our previous page, we said cosine alpha is square root of 7 over 9. And cosine beta we said was square root of 5 over 3. Minus sine alpha, which was square root of 74 over 9. Times sine beta, which is negative 2/3. Well, 7 times 5 is 35, so we got square root of 35 over 27. A negative negative is positive, and we got 2 square root of 74 over 27, which would give us square root of 35 plus 2 square root of 74 over 27. Okay, so let's darn it. I think my wife's trying to kill me. She's turned the air conditioner off, I think. Somebody call 911. C, we got sine alpha minus beta. Okay, so let's go look that formula up. Sine alpha minus beta. Sine alpha minus beta. Sine alpha cosine beta. So sine alpha cosine beta minus cosine alpha. Hey, leave that door open, man. I'm dying here. I need air. There. Okay. Yeah, turn it just like that. Perfect. Thank you. My son saved me. Okay. Sine alpha minus beta. Cosine alpha sine beta. Okay, so from our other page, we said sine alpha was square root of 74 over 9. And cosine beta was square root of 5 over 3. Minus cosine alpha, which is square root of 7 over 9, times sine beta, which is negative 2/3. And that gives us 370 over 27. Negative negative is positive. 2 square root of 7 over 27. So then that becomes square root of 370 plus 2 square root of 7 over 27. And that's your answer. Now D says find tangent of alpha minus beta. alpha minus beta. Let's go look the formula up. Tangent alpha minus beta is tangent alpha minus tangent beta over 1 plus tangent alpha tangent beta. Now let me go double check those. Oops. Okay, 1 plus tangent alpha times tangent beta. Yeah, that looks right. Okay, so from our other sheet, we said tangent alpha was square root of 518 over 7 minus tangent beta, which is negative 2 square root of 5 over 5 over 1 plus tangent alpha, which is square root of 518 over 7 times tangent beta, which is our negative 2 square root of 5 over 5. Now, let me simplify that a little bit. So that's square root of 518 over 7, and negative negative is positive. 2 square root of 5 over 5. 1 plus, okay, I lie, 1 minus. And multiply these together, and we get 2 0 4 5 9 25 90 over 35. Let me double check that. 0 4 5 9 25. That looks right. Okay. Now we want to get rid of the fraction within the fraction, our complex fraction, so multiply everything by 35. So multiply that times the square root of 518 over 7 times the 2 square root of 5 over 5 times the 1 and times this huge fraction. Well, 35 and 7 both divided by 7. That gives me 1 there. That gives me 5. 35 and 5 both divided by 5. That gives me 1. That gives me 7. And 35's cancel here. So we got 5 square root of 518 plus 7 times 2 is 14 square root of 5 over 35 times 1 is 35 minus 2 square root of 2590. Okay, so continue it up here, I guess. We can't have a square root downstairs, so we'll multiply top and bottom by the conjugate of that bottom. So we got 5 square root of 518 plus 14 square root of 5 over 35 minus 2 square root of 2590 times 35 plus 2 square root of 2590 and multiply top part by that too. So we've got 35 plus 2 square root of 2590. Okay, so up on top, let's see, 5 times 35 is 175. Square root of 518. Now this one times this one, we get 10. And 518 times 2590 gives us 1620. This one times this one, 14 times 35, 490. So 490 square root of 5. And then this one times this one, 14 times 2 is 28. And square root 2590 times 5, 2590 times 5, 12,950. over 35 times 35, 1225, minus 2590 times 2, or wait a minute, times 4. So 10,360. Now I'm not going to simplify this down any further. I mainly just want to get rid of the square root downstairs there. That'd just be futile to go that further. Now the ones in the book will work out nicer than that, but again, I'm just giving you the general concept. The key thing to remember is just to get rid of the radical downstairs. You multiply top and bottom by the conjugate of that, which is the first and the second are the same. Sign in the middle is different. Let's look at our next problem. It says establish this identity. So we've got cosine of pi half plus x is equal to negative sine x. Well, we're going to start with this side and work with that. And we got cosine, and what we're going to use is this is alpha, and this will be our beta. So let's go look those up. Cosine alpha plus beta is equal to cosine alpha cosine beta. So cosine alpha cosine beta minus sine alpha sine beta. Okay, so let's plug in what we got. We said alpha is pi over 2, and then cosine beta, which is x, minus sine alpha, which is pi over 2, and sine beta, which beta is x. Now, cosine of pi over 2 is 0. So that's 0 times cosine x, minus sine of pi over 2 is 1 times sine x. Well, 0 times that drops away, and we got negative 1 times sine x, which gives us negative sine x, which is our right side. So we're done with that one. Let's take a look at this one. We got cosecant alpha, cosecant beta, over cotangent beta plus cotangent alpha, and equal to cosecant alpha plus beta. Well, I want to start with this one, and we don't have a formula for cosecant, but we can rewrite that as 1 over sine alpha plus beta. So let's go look up our formula. Sine alpha plus beta is sine alpha cosine beta. So 1 over sine alpha cosine beta, and sine alpha plus beta, cosine alpha plus sine beta, cosine alpha plus sine beta, cosine alpha sine beta. Okay, that looks right. Look at the formulas. Here we have something up on top, here we have something up on top. Here we have something plus something, something plus something. Well, to get a cotangent beta here, cotangent is cosine over sine, so I'm going to divide this by sine beta. We can't just divide that, though, by sine beta. We have to divide everything by sine beta. So this will be sine alpha cosine beta over sine beta. And then this one, cosine alpha sine beta over sine beta. So I'm dividing everything by sine beta. Okay, now that would give me my cotangent beta. Now this other one is cotangent alpha, and cotangent alpha is cosine over sine, so I would need to divide this by sine alpha to get what I want there. But again, we can't just do that one, we have to do everything. So I'll put sine alpha here, and sine alpha here. Okay. So 1 over sine beta is cosecant beta. 1 over sine alpha is cosecant alpha. Now here the sine alphas will cancel, and here the sine betas will cancel. So we've got cosine beta over sine beta, that's cotangent beta, plus cosine alpha over sine alpha, that's cotangent alpha. Cosecant alpha, cosecant beta, which is basically it. I mean, I'd flip around the top part, but that's trivial. So that's your answer. Or I shouldn't say that's your answer. That's we verified the identity. Let's take a look at our next problem. And I'm going to save this and start it on a new page. Number 9. Okay, we got sine, and then inverse sine of 8/17 minus inverse tangent of 15/8. Well, we're trying to match it up with the formulas, so I could say this is alpha, and I could say this is beta. And so then our formula we're looking at is sine alpha minus beta. Sine alpha minus beta. Sine alpha cosine beta. So sine alpha cosine beta minus cosine alpha sine beta. Okay, so that's the formula we're going to be working with. So this right here I can rewrite as sine alpha, and we said alpha is the inverse sine of 8/17. Then cosine beta, and beta is the inverse tangent of 15/8, minus cosine alpha. So cosine and alpha is the inverse sine of 8/17, and then sine beta, and beta was the inverse tangent of 15/8. There we go. Well, now in our first one here, that one's pretty easy. I wonder if I shouldn't maybe do them over here. That might be best. First off, we got sine of inverse sine of 8/17. That's our first little piece right here. Well, if this value is valid for this value, then these are just going to cancel each other out, and this will give us 8/17. So this part right here becomes 8/17. Now our next part, the cosine of inverse tangent of 15/8. We set what's inside the parentheses equal to a variable like p. So p is equal to the inverse tangent of 15/8. We take tangent of both sides. And we get tangent p is equal to 15/8. And remember, tangent is y over x. So y is equal to 15 and x is equal to 8. Now, where we're looking at quadrant-wise is inverse tangent is valid here and here. And specifically, here we're saying tangent is equal to a positive number, which is here and here. So we're dealing with quadrant 1. Now, let's find r. So we got r squared is equal to x squared plus y squared. R squared is equal to 15 squared plus 8 squared. And let me get my calculator, do part of it there. So 15 squared plus 8 squared, 289, which tells us r is 17. Okay, so now after we found x, y, and r, we want to find our outer trig function. This one right here. And cosine is equal to x over r, and x we said was 8, and r we said was 17. Which means that this part will be 8 over 17. Again, what I'm doing, this is 1, this is 2, this is 3, and this is 4. So we just found this value, we just found this value. Well, now we need to find our third one. Okay, so we got 8/17. Okay, so we set our what's inside of parentheses equal to a variable like p. So p is equal to the inverse sine of 8/17. Take sine of both sides, and we got sine p is equal to sine of the inverse sine of 8/17. So we get sine is equal to 8/17. Now, sine is opposite. Sine is y over r. So y is equal to 8, and r is equal to 17. Now, the quadrant we're dealing with, inverse sine, is valid here and here. And here we're saying sine is equal to positive, which is right here and right here. Sine is our y value. So we're dealing with quadrant 1. So let's find x. So we got x squared plus y squared is equal to r squared. So we got x squared plus 8 squared is equal to 17 squared. 17 squared, 289. And take the 8 squared over, that's 64. 289 minus 64, 225. So we get x is equal to plus or minus square root of 225, which is I think 15 squared. Yep. So we got plus or minus 15, but since it's in quadrant 1, it's positive 15. And again, we're trying to find the outer trig function, this one right here. So cosine is x over r, which is 15 over 17. So, this one, next one's 15 over 17. Now our fourth one. Not a room there, so let me just do it right up here. Okay, our fourth one is sine of inverse tangent of 15/8. Now notice this one right here is the same as this one right here. So that saves us a lot of work. We just know sine is equal to y over r, and from this one here we said y was 15, and r we said was 17. So this one will be 15 over 17. Okay, so now we got those. So that gives us 64 over 289, I believe. Yeah. So 64 over 289 minus 225 over 289. 64 minus 225 gives us negative 161 over 289. Long problems. Okay, so let me save this. And then we'll look at the next problem. Okay, so we got tangent of the inverse sine of 1/3 plus pi over 3. Now this is going to be our alpha right here, and this will be our beta. So let's write down our formula. Tangent alpha plus beta is equal to tangent alpha plus tangent beta over 1 tangent alpha 1 minus tangent alpha tangent beta. Okay. So if I got alpha and I got beta here, that means I can rewrite it using this formula. So this down here becomes tangent alpha, which is inverse sine of 1/3, plus tangent beta, which beta is pi over 3, over 1 minus tangent alpha, that, times tangent beta, which is tangent pi over 3. Okay, so over here on the side, I'm going to find our tangent of the inverse sine of 1/3. Again, we start with what's inside the parentheses, set it equal to a variable. So p is equal to inverse sine of 1/3. Take sine of both sides, and we get sine p is equal to sine of the inverse sine of 1/3. So we got sine p is equal to 1/3. Now sine is equal to y over r. So y is 1, r is equal to 3. Quadrant-wise, inverse sine is valid here and here. And here we're saying sine is positive, which is here and here. So we're dealing with quadrant 1. Well, let's find x. So we've got x squared plus y squared is equal to r squared. So x squared plus 1 squared is equal to 3 squared. So we've got x squared plus 1 is equal to 9. Take the 1 over. We've got x squared is equal to 9 minus 1. X squared is equal to 8. Drop the squared, put a plus or minus square root around the other side. And we get plus or minus 2 square root of 2. Now, in quadrant 1, x is positive, so x is equal to 2 square root of 2. Now we're looking at our outer trig function, which is tangent. Tangent is equal to y over x, and y we said was 1, and x is 2 square root of 2. We'll multiply top and bottom by, that's 2 square root of 2. Multiply top and bottom by square root of 2, and I get square root of 2 over 2 times 2. So you get square root of 2 over 4. And that's your tangent. So square root of 2 over 4. So that's square root of 2 over 4 plus, and down here that's 1 minus square root of 2 over 4 times. Now tangent pi over 3. Here's pi over 3. Tangent is y over x. So I got this over this. The 2's would cancel, and we got square root of 3 over 1, which is square root of 3. And then square root of 3 down here. Well, I can multiply everything by 4 to get rid of the fractions inside here. So 4 times square root of 2 over 4. 4 times the square root of 3. 4 times 1 minus 4 times square root of 2 over 4 square root of 3. So that gives us square root of 2 plus 4 square root of 3. This gives us 4, and those 4's cancel, minus square root of 2 times square root of 3 gives us square root of 6. Now we can't have a radical downstairs, so we'll multiply top and bottom by the conjugate of the bottom. So we got square root of 2 plus 4 square root of 3 over 4 minus square root of 6, and multiply top and bottom by 4 plus square root of 6. Again, conjugate is the first and second are the same, sign in the middle is different. And whatever we multiply by the bottom, we have to multiply by the top. Okay, square root of 2 times 4 gives me 4 square root of 2. Square root of 2 times square root of 6 gives square root of 2 times 6. 4 square root of 3 times 4 gives us 16 square root of 3. And 4 square root of 3 times square root of 6 gives us 4 square root of 3 times 6. And down below, since these are conjugates, all I have to do is multiply my first parts and last parts. 4 times 4 is 16, minus square root of 6 times 6 is 6. So we've got 4 square root of 2 plus, now 6 we can rewrite as 2 times 3, plus 16 square root of 3, plus 4. 3 times 6 is 3 times 2, and that gives us 10. Well, here we got 2 times 2, so we bring a 2 out, and that gives us 2 square root of 3, plus 16 square root of 3, and here we got a pair of 3s, so we'll bring that out, and that gives us 4 times 3, or 12 square root of 2, over 10. Well, 4 square root of 2 plus 12 square root of 2 is 16 square root of 2. 2 square root of 3 plus 16 square root of 3 is 18 square root of 3 over 10. Remember from college algebra, if you can divide this number, and this number by saying remember do so, and they're both divisible by at least 2. So that gives 8 square root of 2 plus 9 square root of 3 over 5. Assuming I haven't made any kind of math error, like adding, multiplying wrong, which very easy to do on these. Okay, 7. And let's look at our next example. And let me kind of shift my position here. There we go. We got secant of inverse sine of u minus 3 plus inverse tangent of u minus 5. And this is write each trig expression as algebraic expression containing u and v. What we're going to find is, since I put extra items in here that the book didn't have, this will be a little bit more complicated in the books, and you can't like get u and v by themselves strictly. Well, you probably could, but it's not worth the effort. We're just basically going to use our formula to rewrite it. Now we don't have a formula for secant, but that's okay. We have a formula for cosine. So I can rewrite this as 1 over cosine of inverse sine of u minus 3 plus inverse tangent of u minus 5. Now this is going to be alpha, and this will be beta. And our formula is cosine of alpha plus beta is equal to cosine alpha cosine beta minus sine alpha sine beta. So that's our formula. Which means the bottom part we could rewrite as 1 over and cosine alpha. So we've got cosine of the inverse sine of u minus 3. And then cosine beta, and beta is inverse tangent of u minus 5. And minus sine alpha, and so we get sine of alpha, so that's inverse sine of u minus 3 times sine beta. So we got sine of beta, and beta is inverse tangent of u minus 5. Okay, so that's what we're going to be working with. I'm not quite sure how to do this, except for maybe I'll come way down here and look at each of these little pieces. We got one piece here. We got one piece here. We got one piece here. And we got one piece here. So cosine, I'm not sure if I've gone down far enough. I'll probably mess this up, but we'll see. Cosine of inverse sine of u minus 3. Okay. Now, remember our steps. We set what's inside of parentheses equal to a variable like p. So we got p is equal to the inverse sine of u minus 3. We take sine of both sides, and we get sine p is equal to u minus 3 over 1. And if I think of it in terms of my x's, y's, and r's, then sine is equal to y over r. So y is equal to u minus 3, and r is equal to 1. And I need to find x. So we got x squared plus y squared is equal to r squared. Now for these, they're challenging enough as is. I don't want you to worry about. It tells you to worry about the conditions, and I'll mention that after I get done with this. Okay, y is u minus 3, so that's u minus 3 squared, and r is 1, so we got 1 squared. So we got x squared is equal to 1 minus u minus 3 squared. So we got x is equal to square root of 1 minus u minus 3 squared. Okay, so, and we're looking at our outer trig function, which is cosine. Cosine is x over r. So we're going to have the square root of 1 minus u minus 3 squared over r, which was 1. So it's just the square root of 1 minus that one, whatever that says. So this first part here is the square root of 1 minus u minus 3 squared. Let me go down and verify that. Yes, it is. Okay. Now, conditions I told you not to worry about. Remember, if we have this set up here, this has to be valid for this over here. Well, remember, cosine bounces back and forth between -1 and 1. So that's saying that -1 is less than or equal to u minus 3 is less than or equal to positive 1. And I could add 3 to both sides. All 3 sides, I should say. And then that would give us 2. And this would give us 4. So that's saying u is between 2 and 4. Now, there's some other considerations we have to take into account on this. Is we'll find that u will be different values for each one of these. So you have to then narrow down your what are valid values for u and v. Again, I don't want you to worry about that. It's not terribly difficult, but I think these are just challenging enough as is. Let's look at our second one. This was our first one. So we got cosine of the inverse tangent. So we got cosine of the inverse tangent of, I think it was u minus 5. Let me go up there and look. U minus 5. Again, we set what's inside the parentheses equal to a variable like p, so p is equal to inverse tangent of u minus 5. Take tangent of both sides, so we get tangent p is equal to u minus 5 over 1. Tangent is y over x, so y is equal to u minus 5, and x is equal to 1. R squared is equal to x squared plus y squared. So r is going to equal the square root of 1 squared plus u minus 5 squared. So r is equal to 1 plus u minus 5 squared. Okay, we're trying to find our outer trig function, which is cosine. This one right here. And cosine is x over r. X was 1, so we have 1 over this square root. 1 plus u minus 5 squared. So let's go put that up there. 1 over square root of 1 plus u minus 5 squared. Minus. Okay. Now, assuming that u minus 3 is valid for sine, and we put stipulations on it to make it valid, then these are going to cancel each other out. So here you're left with u minus 3. Now over here, we already found the inverse tangent of u minus 5. So we know what x, y, and r are. So sine, our outer trig function, this right here, is equal to y over r. So I come down here. This is using the same information as I have here. And sine is equal to y over r. And y we said was u minus 5. And r is equal to this square root. So 1 plus u minus 5 squared. Like that. So I'm going to come up here. And then 1 plus u minus 5 squared. Now it probably isn't worthwhile. I'm just trying to give you the sense of how these work. Probably isn't worth the effort to get this completely in the right form. You know, but we definitely could get rid of this fraction inside of a fraction. Multiply everything by the square root of 1 plus u minus 5 squared. So we'd have square root of 1 plus u minus 5 squared over, and this would cancel away, so we got square root of 1 minus u minus 3 squared minus u minus 3 times u minus 5. And I'm going to stop right there since I'm about out of space anyway, but we'll leave that as our answer. In case you're wondering, well, where in the world is this ever used at? This type of setup, working problems that look like this, would be what you see in Calc 2 with our working some of our trig substitution. There, I started talking and didn't even notice it. I saved that. 11. Yes, it did. Okay. So let's look at our, I think it's the last problem. Yep. So let's look at this one. Tangent x minus square root of 2 secant x equals -1. And wanting to solve this between 0 and 2 pi. Well, one method, again, we've looked at is you can rewrite everything in terms of sine and cosine. Tangent is equal to sine over cosine. Secant is 1 over cosine. Actually, I'm trying to remember how I did this in class. Oh, that's bad. I don't remember. Oh well. So we'll multiply everything by cosine. What you could do is leave everything in terms of tangent and secant and work it that way. Okay, so we'll multiply everything by cosine to get rid of that fraction. There we go. Those cosines cancel there. Here's these cosines cancel. And we're left with sine x minus square root of 2 is equal to negative cosine x. Now I can square both sides. So I got sine x minus square root of 2 squared is equal to negative cosine x squared. So when I square this, that's like taking sine x minus square root of 2 times sine x minus square root of 2. And when I square that, of course, the negative squared just becomes positive. We just got cosine squared. Over here, sine times sine is sine squared. Sine times negative square root of 2 is negative square root of 2 sine. Negative square root of 2 times sine is negative square root of 2 sine. And negative times negative is positive, and square root of 2 times square root of 2 is 2. And I'm going to go ahead and rewrite the cosine squared as 1 minus sine squared, because we want to get them all in the same trig function if we can. So take those over to this side, and we get sine squared plus sine squared, and minus 2 square root of 2 sine x plus 2 minus 1. Which gives us 2 sine squared minus 2 square root of 2 sine plus 1. And seems like I'm missing something. Maybe not. Maybe it'll factor. To get this, I could have square root of 2 sine x and 1, and square root of 2 sine x and 1, and minus minus. Let me see if that works. That's 2 sine squared, negative 2, negative 2. Yeah, that worked. Now, what made me think of that is when you got a problem to be factored, and you got a square root in here, always look for, take a look at your first item here, and what times itself gives you that. Well, square root of 2 times square root of 2 gives you 2, and sine times sine gives you sine squared. And over here, 1 times 1 gives you the 1. And then it repeats like that. Well, then I'll set that equal to 0. Since they're the same, I only need to set 1 equal to 0. And we got square root of 2 sine x equals 1. Divide both sides by square root of 2. We got 1 over square root of 2. So we get sine x, multiply top and bottom by square root of 2, and you get square root of 2 over 2. And these are the square root of 2 over 2 Let's see. Sine is our y. That's going to be pi over 4 and 3 pi over 4 if I look at my unit circle. Now, as you there's a couple things we did here. We changed it to other trig functions, and we also took both sides to a power. Well, either one of those would cause us to need to check our answers, but both of them definitely. Pi over 4. If I put pi over 4 in here, that's 1. And I put pi over 4 here, that's 2 over square root of 2. The square root of 2 is canceled. I got 2. So we've got 1 minus 2, which checks. If I put 3 pi over 4 in here, tangent of 3 pi over 4 is negative 1. And if I put 3 pi over 4 here, secant of 3 pi over 4 is going to be negative 2 over square root of 2. The square root of 2 is canceled. Negative is positive, so we've got positive 2. Negative 1 plus 2. Did I give you negative 1? No. So our only answer is the pi over 4. And let me save that. There we go. And that's our last problem. So I guess I can stop the recorders. Sum and difference formulas. There we go. And